The biggest fear that any maker like myself has is that once you do make a thing, nobody will want to buy it. And this past Thursday, which is when I released the video in which I announced our 3-month pre-order period, I physically felt sick in my stomach a couple of hours prior. What if there's nothing but crickets? I asked my wife. What if people were just nice to me because, I don't know, they like the content but not enough to take a chance on what we've worked so hard towards more than over a year now? Well, as you can tell by the huge smile on my face, those fears were completely unfounded because after the video was out, we got 1,000 pre-orders in 3 days. You heard that right? 3 days. Now, some of you might argue that those are not real pre-orders because at the time it was just a mailing list subscription, one that showed intent, yes, but not one that actually made people pull out their wallets. Well, I got more good news because, as they say, strike iron while it's hot, which is why upon seeing all those subscriber numbers going up, I pretty much immediately set up a Stripe payment form, and in Tuesday, so 5 days later, I not only replaced the subscription form with the link to the payment form, I also sent out an email to all of the 1,000 and something people that showed intent. And to this day, so 3 days later, more than 280 of them already wired their $100 reservation fee, which is like insane. Honestly, I'm humbled, I'm honored, and I'm grateful for the amount of trust you put in me. Seriously, thank you. Words don't even start to describe the fact that you decided to actually deposit $100 to support a project that, you know, 2 random dudes on the internet are trying to build a business out of. And this is why I think I have the best channel on YouTube. It's not because of me, it's because of you. Thank you. Now, obviously, because there's a lot of work involved in setting all these things up, so the payment form, the mailing list, the simple landing page and whatnot, there's a lot of questions I believe went unanswered, especially for those who don't see each and every video that I put out about the project. So allow me to spend the rest of this video addressing some of these questions, and if by the end you're convinced that you do want to support us like the 280 others that have already done so, I'll leave a link to the pre-order page down in the description of the video. From what I've seen in the comments of my previous video, they kind of fall into 3 different categories. So A, hardware and features, B, software and operating systems, and C, let's call it logistics. And I'm not talking about shipping here, but about licensing, documentation, and open source aspects of the device. But before we get there, let's talk about the name of the device, because I think a sufficient enough amount of commenters had an opinion that I think it warrants a response, so here it goes. I chose Gateway because it's easy to remember, is exactly what the device is, and best of all, because it's a dictionary word, it means that nobody can register it, not even us. And honestly, that's perfectly fine by me, because guess what? Nobody ever bought, or didn't buy for that matter, a particular device because of its name. I mean, my digital to analog converter is called RME-ADI-2 DAC-FS. And you know why I got it? Because it sounds good. So, Gateway it is. Some people love it, some people don't, and that's perfectly fine by me, because we'd be looking at the exact same outcome even if I chose any of the other 50 great ideas that came in. The most common question that's been a reoccurring one for months now and is a deal breaker for some unfortunately are the 3 gigabit RJ45 ports, or why can't we replace them with 2.5 gigabit ones? Well, unfortunately, we simply cannot. You see, the total bandwidth of the CPU we have on the board is 26 gigabits, 20 of which are taken by the 2 SFP Plus ports. This leaves us with 6 gigabits, so one might think we would be able to put at least 2 2.5 gigabit ports on it, but unfortunately, that's not how it works. The CPU has 6 of what are called SerDes lanes, and think of these as wildcard interfaces that can, through some configuration, become one of the network interfaces such as XFI, or they can even turn into SATA or PCIe 3.0 lanes. But there are limitations, and not every SerDes interface can turn into whatever we want. I'll show you the table from the datasheet that shows all possible combinations, but the bottom line is that if we wanted to have, say, 4 2.5 gigabit ports, then we'd need to sacrifice one 10 gigabit one. But we decided not to do so, because I think it's still easier to break out a single 10 gigabit port into multiple 2.5 ones with a switch than it is to combine 4 2.5 gigabit ones into a 10 gigabit one with link aggregation. So we're sticking with two 10 gigabit ports and 3 gigabit ones because we believe it's the most optimal way of allocating the available SerDes lanes. Now, yes, obviously we could pick another CPU with more of these SerDes lanes, but well, that comes at a cost. Literally, the Layerscape LS1046A that we're using in our board costs around $70. But if we went with, say, LS2088A, that I think is the first in their lineup that does support all of what many of you are asking for, so at least two 10 gigabit ports as well as several 2.5 gigabit ones, then the price of the board would pretty much double, which is why we decided against it. And speaking of gigabit ports, the fact that we went with unshielded ones really rubbed some of you the wrong way. But honestly, it shouldn't, because for Cat5e standard, you don't even need a shielded cable that's a way bigger introducer of issues, and it still needs to support gigabit speeds on cables that are up to 100 meters long. And I'll prove this in one of the future videos, but in this one, let's instead briefly talk about Wi-Fi. Briefly, because I'm of the opinion that for a proper home network, you need all the members of the holy networking trinity. A router, a switch, and an access point, and each of these should be good at the one function they bring to the table. The router should do the routing, the switch should do the switching, and the access point should do the pointing? Sorry, I had to. Anyway, even with the fact that the main focus of our device is routing, we decided we can and will support various wireless protocols because we also realize that not everyone needs or wants a dedicated access point. Now, here comes the interesting but not so fun part. You see, the interfaces that various wireless chips use in order to talk to the CPU are all over the place. If you want Wi-Fi 6 chip, it uses PCIe lanes to do so, but if you want the Bluetooth or Thread support, then you need SPI, I2C, and even UART interfaces to achieve that. And that's exactly the reason why we have not one but two M.2 ports on the PCB. Despite the fact that both are using key E connector, one is using a single PCIe 3.0 lane for a Wi-Fi 6 2x2 card, while the other is using the SPI protocol for Wi-Fi 5, I2C protocol for Thread, and UART for Bluetooth. Now, I'll stop here because I could rant on and on about how different manufacturers somewhat loosely interpret the standards, but we'll instead just wrap this up by saying that, yes, our board will support a number of different M.2 2230 cards. In fact, we already received u-blox samples for both ports, but you'll have to purchase those separately, meaning that neither the development kit nor the final two versions of our router will ship with those by default. I already briefly mentioned our chosen CPU, which some of you have expressed disappointment over because it's an ARM CPU, and while I do understand that for most x86 is a more familiar territory, you really shouldn't obsess over this choice too much, because I strongly believe it's the right tool for the job kind of situation. You see, your typical AMD or Intel CPUs are general purpose processors, meaning they're jack of all trades, good for a little bit of everything, but not great at any specific task. This is why you have GPUs, for example, because a GPU is orders of magnitude faster at graphic rendering and, well, crypto. In fact, back in the early days, I did look at embedded Ryzen CPUs as a potential candidate for our device, but was told to not even bother unless my first order was at least 100,000 units. Yep, you heard that right, there was no way for us to order, say, 1,000 units. The number is way too low for AMD to even bother with us. I don't like it, but I do understand it. Now, luckily for us, NXP, the makers of the CPU we did end up using, have no such limitation, so I can buy one, 10, 1000 or 100,000, and regardless of the number, I will be able to get them. Plus, they have another ace up their sleeve, and that's the ASIC part of the chip that's dedicated to networking. In one of my previous videos, which I'll put in the description, I showed how it can process 10 gigabit traffic with zero utilization of the 4 general purpose ARM cores that are also on the chip, which leaves them to do, well, anything that's not networking related. I'd like to see your Intel N95 do that. My point here is that we strongly believe that the CPU we did end up with brings the best of both worlds. So, offers functionality that 99% of our target market needs in a device like this, and is also priced right and available in any quantity to a small startup like ours. This episode is brought to you by PCBWay. I've been working with them on my custom keyboard project, and I was super impressed with their speed, quality and price, so I'm more than happy to recommend them to anyone who needs any kind of PCB manufacturing done, whether it's just for a couple of prototypes or if you need a larger production run. Link to their website, of course, down in the description. Back to the video. The one question that also frequently pops up when talking about hardware is whether we'll open source that as well, so the schematics and the layout, and the answer to that is I don't know yet. I mean, don't get me wrong, in a vacuum I'd absolutely love to. There's a ton of great stuff in there that all of us could learn a lot from. But unfortunately, we don't operate in a vacuum and competition exists. And with all the noise we're making here on YouTube, this competition has started to pay attention, which is both amazing and terrifying at the same time. Now, how much effort do you think a company much larger than ours would need to go through to take our open source layout, manufacture a bunch of boards almost overnight, and flood the market with them at a cheaper price? I don't think it would take that much effort at all, which is why I'm a bit cautious here and rather not promise anything. I'm personally heavily inclined towards open sourcing at least the schematics, because turning those into a fully functional product isn't as straightforward as having the layout files available. But I imagine we'll have a ton of internal discussions on the topic before we do that, just to make sure that we cover all our bases. And while we're talking about open source, let's also talk about OS itself, which, as you probably know by now, I'm a huge fan of choice. So to all of you who have been asking, will our device support this and that? My answer is yes, as long as the OS you have in mind can run on our hardware. We chose OpenWRT for the development kits because A, we know it works, B, we know it works well because we tested it, and C, because NXP provides source code and binaries which are specifically built and optimized for OpenWRT to utilize the hardware offloading capabilities of the CPU. That being said though, I did successfully build and run ViOS on the CPU development board, as well as plain Debian Linux both with VPP and DPDK, and they all ran fine. And before you ask, yes, we do plan to test both pfSense, pfSense and OpenSense, because honestly I see no reason why either of the two wouldn't run on our device. Subscribe to the channel if you want to see the results once we get that far. Bottom line, open source software, yes. Open source hardware, not entirely. At least not yet. Okay, now let's talk about pricing. I fully recognize that $600, which is how much we decided to charge for the development kit, might be too steep for some people. So, in the sake of transparency, let me lay out all the costs associated with the manufacturing of the device. Just keep in mind that all the quotes we've received from the manufacturers so far have been based on 1,000 units purchased or manufactured. By far the most expensive part of this equation is of course the PCB, and because we're a nobody at this point, we have no kind of purchasing/negotiating power, which means we're paying the full price in a manner of speaking. I'm saying this because I do have a couple of mentors and advisors from the industry, and every one of them said it's possible to knock this price down substantially when purchasing tens or even better, thousands or hundreds of thousands of units. We're talking 30 to 50% here. But because we're working towards ordering our first 1,000 units, we have no choice but to take what we're offered. And what we're offered is 296 euros per finished PCB. As I said in my previous video, this can and will be optimized for the 2 certified versions of this device, regardless if we have any negotiating power or not. As an example of these optimizations, we already received offers for drop-in replacement for our SFP Plus cages, bringing the price of each from around 4 euros all the way down to 80 cents. Yep, you heard that right, 80 cents. And because we have 2 of these connectors, that means we can save just over 6 euros here. Now, it might not sound much, but once you start applying this approach to all the other components as well, it of course adds up. And from all the alternative offers we've gotten so far, as well as our plan to optimize the storage, memories, and the number of sensors on the board, we're pretty confident we can get the PCB price down to around 200 to 230 euros instead of 296 we've been quoted for the development kits. We'll of course talk much more about this when we get there. The point I'm trying to convey here is that when it comes to hardware development, there's always a balance between price of production, quality of the parts, and how much people are willing to pay for when it's all put together. And if you only look at the comments of my previous video, then you'd think that $600 is way too much, because let's be honest, for some people it definitely is, but the fact of the matter is that that would be the case regardless of the price. Even if in some parallel universe we would be able to sell this device for say $100, I guarantee you that someone would complain how that's still too expensive and they can get a router for half that price on Temu or Wish. The second most popular type of comment, on the other hand, was one that said we shouldn't do the CNC aluminum edition because obviously it increases the cost of manufacturing substantially, and I've even admitted as much myself. That being said though, people have reached out saying how good it looks and they'd absolutely love to purchase a unit, even, or should I say despite the fact that it means paying a little bit more for it. So, what do? Well, it's easy. We make both the CNC milled enclosure for people that want it and are willing to pay a bit more, and the sheet metal version for people that won't. You're happy, I'm happy, everyone's happy. But since we're talking about the development kit today, we're going with the third option, and that's the polycarbonate enclosure. We already received a quote for 1,000 pairs, and I'm saying pairs here because the development kit enclosure will be made out of 2 parts, so the top and the bottom. And the price we've given is 38 euros, which means that with the PCB, we're currently at 334 euros. But we're not there yet, because we also need to add the price of the fan, which is around 4 euros, a heatsink, which is another 4 euros, a power supply, which is 10 euros, around 2 euros worth of screws, and finally, because the development kit will be rack mountable, and the ears for that, also add another 4 euros or so. The only price I have not looked at yet, like at all, but honestly doesn't add more than around, let's estimate, 10 euros to the final price, is the packaging, which means that all these numbers combined bring us to 368 euros, if my math is correct. Now, because most of our suppliers charge us in euros, but we're a US-based corporation, so we want to base our prices towards end customers, that is, in dollars. So if we convert the 368 euros to dollars, we get around $380 per one finalized and packaged development kit. And that, my dear viewer, is bad. Trust me, if any first-party manufacturer of electronics equipment is watching this video, then they're most likely either laughing or crying, because 36% margin is a bad margin. In fact, I recently spoke to someone that's working for a fairly well-known global brand of electronics, and he said they always aim towards 80% margins, which means that the actual cost to manufacture a product that they sell for $1,000, for example, is, you guessed it, $200. But hey, you're making more than $200 per board, I might hear some of you say. And yes, that's absolutely true. But what you need to think about here is the context. And in the case of our company, we have 2 people working full-time on this, so me and Aljaž. Then we have a couple of guys that help us out part-time, which pretty much adds up another full-time salary. So 3 salaries plus a bunch of services and licenses we need to pay for in order to successfully develop the product, and we get to around $15,000 to $20,000 spent each month. With $200 per device, this means we need to sell 100 of them each month just to sustain the business in its current state. But long term, to be honest, 3 guys is not even remotely enough to develop, build, market and sell a single product of this type, let alone several of them. But even if that were the case, imagine we made $400 per device. That would mean we'd be able to hire twice as many people for the same amount of routers sold. This is an example, of course. What I'm getting at here is that this is a numbers game. The bigger the margins, the bigger the profits, the more you can invest back into the company and have better products, faster development cycles, better support, more documentation, etc, etc. Now, before we wrap this part up, let me give you an even more extreme example when it comes to margins. One that literally everyone is familiar with, most just don't know how much they're getting screwed over. Glasses. There was a frame factory here in the region that got shut down just a couple of years ago, and as it just so happened, I was interested in one of their laser engraving machine at the time, so I paid them a visit. You know how much their most expensive frame costs? You know, the one that then gets Tommy Hilfiger or some such sticker on and is then sold for hundreds of euros? 12 euros. And no, despite what they'll have you believe, lenses aren't that expensive to make either, unless it's something really out of the ordinary, but we're still talking anywhere between 5 and 10 euros per lens. I mean, don't get me wrong, high margins are good because, as I said, you have more resources at your disposal to hire up and grow the business. But, in my opinion, the value of the product you're buying needs to justify those high margins, and in the case of glasses, I just think it doesn't. I mean, you get into the store, you try a couple of them to find a pair that you think looks best on you, you pay for them, and you leave. When I started this channel, I've kinda set 3 guiding principles for myself that I would do my best to follow at all times, and in no particular order, these 3 are: A. Teach people something, whatever, as long as one person learns one thing in each of my videos, then I personally consider it to be a success, regardless of what YouTube analytics say. B. Be kind and positive, because, well, I think we can all use some more of both, right? And C. Don't engage in hate. Well, today, just for this one special occasion, I'm going to break the last one, because someone special decided to spread hate in the comments of my previous video, attacking and insulting both me, this project, and anyone that had anything positive to say about what we're building here. Needless to say, I instantly removed them from the channel so they can't comment anymore, but in the off chance they're watching this anyway, here's what I have to say to them. Be kind to your fellow human beings, regardless if you agree with them or not, and you will see your world turn for the better almost immediately. And best of all, it doesn't cost $600 to do so. In fact, it's completely free. Tomasz from Slovenia, signing out.